Till now, we have seen the Solidity programming. Then now we'll move on to the usage of this smart contract. First, for this, I will open the Chrome browser. Here also you may type the remix.ethereum.org. Whatever the code we have seen, this one, this you can directly copy and paste here. So already this particular program consisting of box.sol. So already whatever the image I have provided in that you will be having this box.sol already installed in this, already set up in this. So just you click on box.sol. So the same program that I have shown just now, you will get it. So in order to work with the constructor, you have to use the function called constructor, just like this. Here you want to make the constructor, and constructor public. Then you may use height is equal to 10, width is equal to 10, depth is equal to 10. Now just to go for deployment, and here problem is this now. Here you can delete this instance, deploy it, and here I'm not going to set any dimension, just compute volume. Directly you will get 1000. The reason is when the instance is created, constructor will be called. In the constructor, this height, depth, and width have been instantiated. So directly, whenever you compute the compute volume, automatically you will get the 1000 as a value. This is the constructor. So same program that you can see here also. The main theme of this program is to show you how can you work with the contract and how can you link with the decentralized application. As I told you in the morning session that you have three networks: main network, test network, and local node. So we may create a local node and run it, or you may take the services of creation of the local node, such as Ganache or remote test RPC, and with that we may connect to the web application. In order to do that, in the deployment, the Remix IDE is providing you the default accounts like this. But if you are running the smart contract on the local environment, then how to do that? To do this, you have the options. There are several options available. The first option is make use of the test RPC. Test RPC sudo or you can say apt get install Ethereum -test RPC. So this particular command will install the test RPC, or else just you type dir, and here you will find Ganache 2.5.4 Linux image. So just you can run it /Ganache. So this will open the GUI version of the remote procedure call of for running the toy accounts with toy ether. So this is the Ganache. It will give you the representation like this: quick start, and new workspace. Just to click on the quick start. So it will initiate the accounts for usage, local usage, like how the Remix IDE has initiated the accounts. And these accounts with some toy ethers, how remix ID provided. In the same way, in your local environment, this Ganache will provide you the account. If you want to restore these accounts, these are the mnemonics that need to be remembered. You are always recommended to copy it and save in some place. If the operations are going on, if you want to recover these accounts, you are supposed to copy this mnemonics and has to place it. The reason is these mnemonics will be helpful to you uh, for recovering whatever the forgotten addresses are. Many of the bitcoins lost because the Bitcoin users have forgotten their keys or forgotten their accounts or their password. For that purpose, in Ethereum, there is a small, especially in the case of Ganache and all, there is a beautiful feature called mnemonics. Only thing is these mnemonics has to be has to be copied and placed in a safe position, or you may also make it in a diary, or you can place it in a safe position. So that if you want to recover your account, you have to enter these mnemonics in the same order it was shown at the time of creation. So for example, relay, task, okay, toilet, gadget, this kind of thing is there. So in the same order you are supposed to enter, then only your account will be restored. So this particular thing, this Ganesh is currently running on network ID 5777. This is the test ID, and RPC server localhost 7575. Now this blockchain is running on the localhost 7575. Whenever you write any web application, the web application must connect to this remote procedure call server, RPC server, and the smart contract that is deployed on this server can be accessed with the help of the accounts that were placed. So this is the way how we access the accounts from the Ganache. The Ganache is the GUI version of the test RPC. So if I close this and if I run the test RPC, what the test RPC is doing is it is also giving the command line command based account, right? Ganache core, this test RPC is also to be CLI command line version of the Ganache. Already we have seen the GUI version. With the GUI version also we can connect. So what this particular test RPC is doing, it is also giving you 10 accounts, dummy accounts, and their private keys. With this private key, you can manage this particular account. Along with this private key, you should also remember the mnemonics. So every time you run the test RPC or Ganache, you will get the different mnemonics. Okay, and currently this test RPC is running on the local host 8545. Any doubt so far? Well, now I want to connect my local host, my local server that I am running here, the test RPC. I want to connect it to the remix ID. So to do that, you have, this is already a remix virtual machine, which is running in the London server, and this is Berlin server. Now I will use Ganache provider. Okay, this is the Ganache provider. This I will use this. Click on this Ganache provider. Automatically it is showing you JSON RPC endpoint as 127.0.0.1.8545. Anyhow, this is running on the local host 8545. Okay, remember this address will automatically captured by the remix ID. Then if you click on OK, so custom connection, and this is the network connection. Now you look at list of accounts.
अब तक तो रीएडमिटेड दिखा देते थे वो, अब इस बार तो कोई नहीं होगा मेरे ख्याल से रीएडमिटेड वाला केस। एक बच्चे के नाम पे एक सब।
Okay. Now, if you look at the this is in Windows, right? Now we are what? If you look at accounts 0xEB3 and last account 0x66F, go to the command prompt. Okay, it is floating like anything. Continuous refreshment will happen. So just I'll close it. Let will remember this 0x56A6F, 0x56A6F, and 0x08, 0x56, 0x08. Now, if I connect to this Ganache provider, so 0x56, 0x08. So whatever the accounts were shown here, 0x56 and 0x08. These accounts will be automatically picked up by the remix ID and shown here. Now you don't need to work from the command prompt. You can directly work from the UI and directly your smart contract can be tested with the local network. So this is one way of using the Web3 point of view or local execution environment. If not this, there is another option called injected Web3 or injected provider. Just to click on the injected provider, automatically MetaMask will come into the picture. So for this, so MetaMask will be opened. This MetaMask is a injected Web3 or injected provider. You may remove from Chrome and you may again you install this remix ID, MetaMask for Chrome. You can go to the Chrome store and add to Chrome, add extension. Because whatever the image I have provided, already Chrome extension were added. And whenever it asks for password, you type 1, 2, 3, 4, 5, 6, 8, 7, 8. Because the minimum size of the password in MetaMask is 8 characters. Now it was added to the Chrome. Just pin this and you will find the MetaMask will be open. This is Web3 provider. MetaMask is also a wallet where you can see, you can connect to different things and you can see. Get started. If you already have some recovery phrase, so you can create a wallet and you can add the recovery phrase. So create a new wallet and start recovery phrase. If you don't have that, just have a secret recovery phrase. Then I already have a secret recovery phrase. Then go for importing wallet. Otherwise, just to set up new wallet. So clear. I agree. and you type your password. I'm typing as 1234567. Just to remember this, you never disclose the password out, but I am disclosing because everyone has to use this. You may keep your own password and don't disclose the password out. The configuration is going on now. And be ready with the leaf pad. It's like a notepad. The reason is I need to replace place this particular wallet and mnemonics. So here you can find here secret recovery phrase. Click this, then you will get this secret recovery phrase. Endorse, enlist, ribbon, this kind of thing, Congress, feeling, etc. These are the phrases. These must be kept secret with you. This will help you to recover the account. Next, in order to recover the same order that recovery that mnemonics are there, the same order you have to place. Endorse, enlist, ribbon, Congress, firm, fashion, phone, voice, work, liberty, access, and clear. Then confirm. Congratulations, all done. Now you have been recovered with the account. Now you look at here. By default, the MetaMask is connected to what? Ethereum main network. This is what I'm keep on discussing from the morning. This is already connected to the main network. I don't have any Ethereum account to work with. So I want to connect with some test network. So here you can click here, show or hide test network. In this, you please show the, you just to turn on the option for the showing of the test network and save. So that you will find test network. This is the Ethereum main network. You will find the Robston test network, Coven test network, Ringby test network, and this kind of, and local host 8545 also. Anyhow, already the local host is running here. The local host is running. So you may also plug with this local host, and you can work with the MetaMask. If you want to click on the local host 8545, automatically whatever the accounts were shown here will come into the MetaMask. Or you may also choose Ringby test network. Just I'm going to click the Ringby test network, and or if you want to add manually some network, then you can add manually. So anyhow, I have added the I have used the Ringby test network for this. Then if you use the injected provider MetaMask, then the MetaMask will be opened. So here is the Ringby network. Test ether in Ringby test network provider. So there are some links that will be available where you can place your account number there, so that some toy ethers will be given to you. So anyhow, already these are all providing you toy ethers. No need to go all those things. But if you want to do some experiments in a real test network, then you can have this kind of thing. So why am why I'm saying all these things is there are multiple ways to connect to the network of blockchain which is running, and you can pick up the smart contract from that network. So in all these things, important thing is you can make use of the Ganache or test RPC or the remix test provider accounts providers, this one, or the MetaMask. So all these things are the main goal of all these things are the same. Only thing is to provide the services to the front end application. Any doubt so far? Okay. Next, we'll move on to the topic of thing. Once you have set up this VM, was if a file manager is there, you can go to this file manager. Here you will find web3js underscore pro and web3py underscore pro. These two folders are there. In this web3js pro folder, you will find several programs. Okay, program 1, program 2, 3, 4, 5, 6, 7, up to 7. Each program, what they are doing, are given in the program details. So Web3js is the library used to connect to the front-end application. In the decentralized application, if you look at, I'm not covering how to create the node, cell, and all. That I will tell you. Already some programs were placed in the virtual machine. So you may explore those programs and you can create on your own. Just you follow the instructions provided there and you can work on to that. So here, yeah, DApp structure. This is the web application, that is front-end application. This one is also front-end application, like user 1, user 2, user 3, like that. This front-end application will be accessed by several users. Obviously, this front-end application consisting of Web3 inclusion. That is Web3js inclusion. Now, this Web3js, what it will do is, it will connect to the backend database server, blockchain server, with the help of JSON RP. In order to connect to that, you need to have a URL. What is that URL? Already you have seen here. So what is the URL? Localhost 8545. If you are using local network, if you are using test network, then test network address are placed. If you are using the services like Infura, then you can also go to the Infura services and you can get the things like that. Infura, just you type the Infura and go to the Infura website and log in. Already I have created my own login. You may also create your own login. So that you will get a email verification. So you have to accept the email verification. And this is the class demo test that was created on 2019 for showing to students, I think so. Afterwards, I have not logged into this. So you can also do this and create a new key and this one. And here, create an IPFS project, create as an external project. These are the things are there. Here, create new key, select the network. Here, Web3 API, formerly Ethereum, and my project is demo project. Okay. Here, ETH2, Ethereum 2, Web3 API project, create. So whenever you create it, you will be finding this URL. This is the Infura URL, main network. You can choose which network you want. Ring-B network I'm testing. The Rapston, Coven, and Ring-B, Gorley, these are the test networks. Main network means this is the production environment, main network. You can choose one test network, a Ring-B test network. So the Ring-B related transaction, the Ring-B related URL will be generated here. Just you can copy this URL and place here for the future use. When you are working from the local environment, you will be having this localhost 8545 because this is local environment, but this is the service provider of Infura, who are the service provider of Infura. So this service provider will run the blockchain at the backend. You may deploy your smart contracts on this test network, and your web application may access this URL to get the values from the smart contract, and also you can pass the values into the smart contract. So this is what the what called where if anyone knows this particular URL in my network, if anyone knows this URL, automatically they can connect to the my project. But if I use local network, only the people who are in my network or in the local network can be in a position to access this. But if you place this in a test network, anyone can from anywhere from internet, they can use it because of that URL. That is what the main difference between the local running and taking the service of Infura and this kind of thing, and can make it profit. So this is what the thing, why I'm saying this is important to know. So this program details are there. This program details, installing and configuring Ethereum, installation of Node and NPM. And whenever you connect this URL, there are Web3js versions are there, like Web3js 1.6.1. This is a very stable and latest version at the time when I am creating this VM. And 0.19.0 is somewhat older version, but a very easy version to access. Okay. These two are also installed in this. So here program 1, in the program 1, we have inspected the installation of Web3 and install it globally, like sudo npm install web3-g.
Now we'll move on to the program 4, that is the program 5, that is as per our calculation. So here it is asking that the local host connection was disconnected, so no problem. At present we don't want this particular connection. In this program, I have written a program called box.solve. What is this box.solve? This is a smart contract, box smart contract, where height, width and depth was defined. We can set the dimensions of the box and we can also compute the volume of the box. This program is to demonstrate how to communicate with the smart contract. For this smart contract has been written with the Pragma Solidity 0.5.0. Now, this program can be taken to the Remix IDE and under the contracts. So under the under the box.solve, this program has been placed here. We are going to see how to communicate with the smart contract via front-end application. In order to do this, first we need to run the Ganache-cli. Here don't use test RPC because the test RPC don't have the test RPC don't have the functions to communicate with the DApp application, the decentralized application or front-end application, because it is showing an error called JSON RPC error, or unable to connect with the JSON RPC, or RPC remote procedure calling is failed. This kind of errors we are getting. So to avoid this, we'll use Ganache-cli. Either you may run from the command prompt, or I have already provided a graphical user interface based Ganache client in that I will discuss afterwards, not now. Ganache-cli, run it. So this will also show the temporary accounts, just like the test RPC. So here it also given you the 100 ethers as a toy ethers for deploying your contract and running the contract. Now it is also listening on the local host 8545. So Ganache client CLI and test RPC are almost one and the same, but this is having the perfect implementation or good communication with the procedures have been defined for the test RPC. JSON RPC, and can communicate with the decentralized application. Now once it is turned on, then let us go for compilation process. Here I am selecting the 0.5.0 because the pragma solidity what I have used is 0.5.0, and the compilation is going to happen. The compilation has been done. Just wait for the compilation. So here the compilation has been done, no errors were appeared. So in this, we can also go for the deployment. So before deployment, we'll see the compilation details. If you click on compilation details, we will be having several artifacts that are generated by this remix ID. In this, Web3 deploy, metadata hash, bytecode, ABI, these are the various functions, these are the various artifacts generated by the remix ID, in which the bytecode, ABI, Web3 deploy are useful for us to connect with the smart contract. So this is the remix IDE where you have the contract in a compiled, contract placed, and you have compiled it. Now we need a background server, that is blockchain server, to access this contract. So in order to do that, what I am doing is, in the deployment section, here environment, here JavaScript virtual machine environment is there, JavaScript VM environment is there, injected Web3 and Web3 provider. We are running here the Ganache client, which is a Web3 provider for us. Via this, we are going to access the accounts. So make note of this. Here the account is 0x5b3. If you select the JavaScript environment of the remix IDE. Now what I am doing is, I am selecting the Web3 provider. This Web3 provider I am selecting, and it is asking you that, do you want to get connected with the local host Web3 provider? The Web3 provider endpoint is localhost 8545. So here it is asking you for the permission to connect with the localhost 8545. So here, where on which address this Ganache CLI is running on, this is on the localhost 8545. So these two are matched here. So this is the Web3 provider running here. So I'm connecting to this. Okay. Now custom network. This is the custom network, and this is the network. Now in this Ganache client, you look at the communication is going on with the this remix IDE, and if you look at it, the first address is 0xC1F5, and here you will find 0xC1F5. This is the first address. Whatever the addresses here, you can see here, these 10 addresses are appeared in this account section. Now if I deploy, then automatically the amount will be deducted from this 10 ETHs. Okay, for the deployment purpose. I hope by this time you have understood how to connect the environment that is on our local system to the Remix IDE and to test the smart contract. Now we'll inspect the HTML code. In this HTML code, here we need to visit the Remix IDE, copy this box.sol solidity file, compile the program, we have run it, run test RPC or Ganache client. Here I will recommend only Ganache client, not test RPC. In Remix IDE, under deploy and run, select a Web3 provider and connect to the localhost environment. So we have connected to the localhost environment. Now this web application starts. So in order to run this web application, I have used Web3 0.19.0 module. 0.19.0 module I have used. So as we know, the standard way of including the Web3js module, this is the script type text/JavaScript src. This is the node modules Web3 distribution web3.js. This is like a header file of C programming or Java programming. We need to include this in our program. After doing this, before going to this, we'll see how this Web3 this index file will look like. So this is a box test. I am writing a front-end application where you have height, width, and depth. And if I press volume, then whatever the values you have entered in the height, depth, width, and depth will be taken and will be passed to the smart contract and will get the result back. This is what the small program to communicate the smart contract with the front-end application. In order to see step-by-step statement or step-by-step execution, if we write console, if we might have given the messages over the console, that can be viewed via more tools, developer tools. So here it will provide you a console. So here it will provide you a console which will give you the details of what is going on. So here in this, the first thing is height. This is the input. Width, this is the input. Depth, it is also input. So the height, width, and depth input has been taken. A form has been taken and a button, volume. So whenever this volume button was clicked, then the action has to be taken place. So this is this is the HTML part. Now after this HTML part, JavaScript part starts. So we all know that JavaScript will be written like this. Script type is equal to JavaScript, text/JavaScript. Now variable web3, for what purpose we are using this web3? So we are going to instantiate the web3 instance. So variable URL is equal to localhost 8545. The reason is the Ganache client is running on the 8545. Now this is the 8545. Type of web3 not equal to undefined. That means if the web3 is null, then instantiate this web3. So web3 is equal to new web3 of new web3.providers.http provider. So because we have seen web3 provider, who is the web3 provider? This is the web3 provider, localhost 8545, that is Ganache client. So we need to take the instance of this, which is happening in the background. So this instance we have taken, and here in place of this, you may also take or you may also supply the instance of any other third-party web3 providers or service providers like Infura or maybe any other provider. For whenever you create the service there, they will give you a URL. That URL will be used in this instantiation. Currently we are working from the local host, so that local host URL is going to be placed here. Now web3.eth.default account. So how can I know these things? So we can come to know this from the documentation of the Web3. So from the Web3 documentation, we can get the details. So here web3.ets.default account, web3.ets.accounts of 0. So I am making the first account as the default account. So that means if I deploy the contract, the deploy amount will be deducted from the first account. So I'm making it as default account. Now after compiling the Solidity code on the Remix IDE, so you can go to the after compilation process, you can go to the compilation details. Under the compilation details, if you look at Web3 deploy, just you copy this Web3 deploy, and if you see here how the Web3 deploy takes is looking like, this is looking like the Web3 deploy looking like this. So variable box contract is equal to new web3.ethereum ETH library dot contract. So where it is available, you look at web3 ETH dot contract. So what this function is taking, or what this constructor is taking, it is taking JSON interface and address options. So what is this JSON interface? The JSON interface is this one. This is called ABI code, which is also called as ABI code, application binary interface. So where you can get the ABI code other than this, so we can also get the ABI code like this. Okay, either you may take the ABI code individually, bytecode individually, you may write the contract function, or directly Web3 deploy is available, directly copy it and paste in the code. And here payable, this entire thing is the ABI code. This is in the JSON format, and this will be taken. So that is what the syntax here, the JSON interface of the ABI code and address of the contract. Here whenever you deploy this contract, here after deploying, we will get the contract address. This is the contract address you will get. So this contract address will be copied and can be pasted. So this is the contract address, it can be copied and pasted. But now we are not going to copy and paste here. We want to deploy from our web application itself, because this instantiation we have made from the outside. Now we want to make it from the web application itself. We want to instantiate from a web application itself. So to do that, this code will help us. Now box is equal to, with this box contract dot deploy, and this is the payload. This is the payload. What is this payload? This payload is nothing but the bytecode. Okay, this is nothing but bytecode. So bytecode is the payload. This bytecode, where it will execute? This bytecode will be executed under the Ethereum virtual machine. So this bytecode is called as payload. That payload will be used here, and arguments send. So under whose account this bytecode or payload to be executed? This payload to be executed from the account 0. Who is this account 0? This is the starting account, and gas points mentioned here, gas limit was mentioned as 4,70,000 or 47000 like that. So whenever it is instantiated, whenever it is deployed, so automatically the payload related gas points will be deducted from the first account's address. And then the instance of the box has been assigned to this box object. Why are this box object? Now we are going to call the functions and send the values to the functions and get the values to the functions. So this is what the skeletal code of deploying the contract from our web application. Now, if we move on to the code, so this same thing, same code has been placed here. Then variable button is equal to document.getElementById volume. Button on click is equal to function. Now, after clicking the volume button, height value has to be get from the HTML page, width and depth, and this height, width and depth must be sent to the box object, that is contract that we have got here. This is the box contract. So from to the box contract, box.set dimensions of height, width and depth. Volume is equal to box.compute volume, and we got the value of volume here. Next, balance is equal to web3 WEI, current balance of web3.eth.default account and ether. And so what after deployment and after computing, whatever is the leftover balance, that will be displayed along with the volume. So here an alert box has been raised. This alert box will give you the volume of the box and the ethers leftover in the first account. Now we'll go to the box test, refresh it, and now height is 10, width is 10 and depth is 10. So the volume of the box is height into width into depth, we should get 1000. So volume of the box is 1000 and the coin base balance is 99.992223. This is the balance left over in the first account. Let us check whether the same account balance is available here in the deploy. So on the first account, 99.92253 ethers. Okay, and here we got 99.9922253. So this is what the balance left over, and the same thing we can also verify via this remix IDE also. So what we have learned out of this is we have written a box.solidity file, and we have run the Ganache client, and via Ganache client we have connected to the remix IDE via Web3 provider. After compilation we deployed it, and after compilation we have gone to the compilation data, and there we have identified the Web3 deploy script. That Web3 deploy script has been used in our front-end application, that is index.html, and via this I got the box contract object, and via this box contract object, whatever the data I have collected from the HTML file via form, fields, etc., that has been passed to the box function, that is setting the dimensions. And after setting the dimensions, we have called the compute function, and the volume has been computed. And finally, the volume of the box and the coin base balance, that is the one who initiated the contract, his balance has been shown onto the screen. So this is the overall program of how to communicate the web application with the smart contract that is running on the Ethereum network.
So this is the way how we are supposed to include it. But in case of this is manually we are doing. When we use the truffle ID, that is command based ID, then it will be very easy. Everything, the compilation process, ABI code generation, everything will be taken care by the truffle ID itself. So if you go to the folder, program 7 is based upon the truffle. So you can go to the remix readme.txt and you can go step by step and execute this program. At the end of this program, it is a complete application, that is along with the web application and light server, everything. It's a full-fledged full stack application connected with the backend blockchain. Program 6 is also like that. It is also based upon the truffle. Okay, and here in every folder you will find the remix ID, readme.txt file, in which it was clearly mentioned what are the steps you are supposed to follow to do this. Next one is along with this Web3js. I will wind up in 2 minutes. So here web3py _pro. Like how you have used web3js for connection, you have to use web3py for connection. So same box.sol, same box class, box constructor, and how you can use the web3, like sudo pip install web3 4.7.2 I have installed, and you can upgrade the web3 also. Then how to import the web3 package, web3 from web3, import web3, and the URL. This is the URL, and if you want to access the inferior URL, inferior URL. Web3 is equal to web3 of web3.http provider of URL. This URL has to be placed. Now the instance of the local host you will get here, and using this local host instance, you go for checking whether it is connected or not. If it is connected is true, then access the latest block or create the block or get the gas price. You do whatever you want. This same thing you can also inject it into the Django or Flask for front-end application development, and you can develop the full-fledged decentralized application development. So this is what from my side related to the Solidity programming and how this Solidity programming after compilation, how the decentralized application will be generated or sorry will be developed with the web3js and web3py. And I have already provided the virtual machine. So in which virtual machine you will be having the various programs which are there in the just go to the folder. There you will find several programs, web3js pro and web3js py. So for each folder you will be having the readme.txt file. You can follow the instructions in the readme.txt and you can make use of that. And if you have any doubt in doing that, you may also visit my YouTube channel. So yeah, I have already placed on chat box. You can open this, and in which you will find blockchain technology and applications in bracket 2021. That folder, that playlist consisting of explanation of all these programs. Okay. If you have any doubt, you can also go through that.